lesson we're going to learn about writing nuclear reactions. The mass and the nuclear charge are conserved in all nuclear reactions. This is due to the law of conservation of mass, which again is the same reason why we balance other chemical reactions. So they either have to have emission or absorption of nuclear particles in order to decay and create new particles. Alright, so let's look at the first example. Here we have sulfur with a mass of 32. And so we need to put in sulfur's atomic number in the bottom, so that's a 16. So it has 16 protons. And then we need to write the formula for a beta particle. So you recall from the previous video, a beta particle is 0 minus 1e. And so we need to make sure that the mass on the left equals the mass on the right. You can imagine your arrow being an equal sign. So since the beta particle has no mass, our missing particle has to have a mass of 32. Sulfur has a nuclear charge of 16. And so the missing particle plus a negative 1 has to be equal to 16. So that's got to be a 17. And so then we look at the atomic number, the nuclear charge, to determine what the element is. So what element has 17 protons? That's chlorine. What type of radiation is this? Well, a beta particle was emitted, and so that's going to be called beta decay. You could also write it as beta emission. So to write this equation out in words, we would say sulfur 32 decays to form chlorine 32 through beta decay. You could also say that sulfur 32 emits a beta particle to form chlorine 32. Or you could say sulfur 32 undergoes beta decay to form chlorine 32. Any of those would be correct. Example 2. Again, we need to put in our atomic numbers, our nuclear charges. Oxygen's an 8, nitrogen's a 7. So again, both sides have to be equal. So 14 has to be equal to 14, which means our missing particle has to have a mass of 0. Remember, we only have two particles that have a mass of 0, a positron and a beta particle. So then we look at our nuclear charge. On the left it's 8, and on the right is 7. So the missing particle has to have a positive 1. And so that's going to be our positron. Okay. What type of radiation would this be? Well, positron is being given off, so that would be called positron emission. So if we write this into words, we would say oxygen 14 emits a positron to form nitrogen 14. You could also say oxygen 14 undergoes positron emission to form nitrogen 14. That would be appropriate as well. Alright, number 3, we have plutonium 242. Plutonium has an atomic number of 94. The alpha particle, that's 4,2He. Again, you must know those particles. Alright, and so the left has a mass of 242, the right has a mass of 4, so the missing piece has to have a mass of 238. So that 4 plus 238 is equal to 242. The atomic number of nuclear charge is 94 on the left. On the right we have 2. So the missing piece has to have a 92, so that 92 plus 2 is equal to 94. Then we look and we find what has a nuclear charge, or 92 protons, and that would be uranium. So what type of radiation is this? Well, it's an alpha particle on the product side, and so that would be an alpha decay. So if we write this into words, we would say plutonium 242 undergoes alpha decay to form uranium 238. Alright, so those are the 3 example problems. In between each of the example problems were practice problems. So I want you to pause the video now and try the practice problems 1, 2, and 3. When you've tried them, come back and restart the video and I'll show you the answers. Alright, so number 1, we end up with a beta decay. So we have bismuth 214 decays to polonium 214 through beta decay. And then in number 2, we have uranium undergoing alpha decay, or emitting an alpha particle, to form thorium-231. Again, the thing to keep in mind is that the left must be equal to the right. So 235 has to be equal to 231 plus 4, and 92 is equal to 90 plus 2. And if you wrote here that uranium-235 undergoes alpha decay to form thorium-231, that too would be correct. Alright, so number 3, we have californium-251 undergoing alpha decay to form curium-247. So for tomorrow, I want you to tell me or write what this answer would be. Writing the balanced nuclear equation for americium-241 undergoing 2 alpha decays. So I'd like you to come to class with that problem done.